Okay, this is the third part of 5.4 video. I'm trying to make them not too long, so bear with me. I'm sure you're putting my voice on dub speed. So in some cases, it's good to actually draw and use geometry to find the area under the curve. So we're going to do that for some of these right now. And hopefully it all makes sense. And then your job will just be to do the homework. So sketch the region defined by the definite integral and then evaluate each integral using a geometric formula. Okay, so before I begin to sketch this, this would be obviously from 1 to 4. And this is the line x plus 3. So 7, let's see, 3, and I go up 1 over 1. There we go. All right. So we want the area under this curve, really this line, from 1 to 4. Kind of looks like a trapezoid, doesn't it? Okay. So if it's a trapezoid, I'm going to find trapezoid. Trapezoid's pretty easy. Trapezoid is area equals half the height times base 1 plus base 2. This is, by the way, a trapezoid that is laying on its side, if you don't remember this from geometry. Okay, so your two parallel sides are your two bases. And they have a length of, what would this be? 4, and then this one would be 5, 6, 7. So 4 and 7. And then the height is 3. And then you just take that and you get 33 over 2, roughly. Now, just to go over something with you, remember this little thing, delta x? Remember delta x was dependent on how many rectangles you made, b minus a. B minus a over number of rectangles. We made 1 there. 3. Height of 3. And your base 1 is actually your f of 1. F of 1 is actually 4. And f of 2 is 7. So just neat from doing everything that we've done with limits and all that, put them together. All right, let's use this one now. If I draw this out, if you don't remember, a square root from -2 to 2. Actually, this is square root of 4 minus x squared. This is actually a semicircle with a radius of 2. Okay, so this one was a trapezoid. This is a semicircle. So area for a semicircle is 1/2 pi r squared. So this would be 1/2 pi. Your radius in this case is 2 squared. Half of 4 is 2, so 2 pi. That's what the area is equivalent to. Okay. Next page. Let's do this one. Ooh, so this one's kind of neat. You can look at this one. This is the absolute value of x plus 3 from -2 to 4. So -2, 1, 2, 3, 4. Remember, if you go to graph absolute value, it looks like a V that has been shifted up to 3 units. And it just goes up 1 over 1, up 1 over 1. And same thing here. So what am I concerned with here? I'm kind of concerned with this area up to this area. Well, that's really like, to me, that looks like 2 trapezoids, right? This would be 1 trapezoid, trapezoid 1, and then this would be trapezoid 2. So let's see, how do I find the area for trapezoid 1? Half height B1 and B2. So this would be half of the height being 2. Your two parallel side bases would be 5 and 3. And that would just be 8. And then this trapezoid right here would be half of a height of 4 times base 1 would be, you could do 3 plus base 2 would be at 7. And again, how am I getting that? If you, what I'm doing is I'm just plugging 0 in right here. 0 plus 3 is 3. That's its height. 4 plus 3 is 7. And you get 20. And then just add these two together. 28. Okay. Next one. Getting done here. The cubic root of x from -4 to 4 is actually, if you don't remember, cubic x is actually an odd function. It has origin symmetry. It looks like, if you don't remember, it kind of looks like this. Okay. And if you're going from -4 to +4, like that, then if you remember what happens there, this is going to be whatever area you get here. In this area, because these are the same values, just one is opposite, you're going to get an area of 0. So there, that lovely trick came into play. Okay, last and final two. 3x plus 2. So this may seem simple again, but let's kind of look at it one more time. Draw this out. 1, 2, 3, 4. And let's draw 3x plus 2. So if I plug 1 in, I would get 5. 1, 2, 3, 4, 5. And if I plug 4 in, I get 14. And of course, I'm going off my grid, so I'm going to pretend 14 is all the way up there. So this is really on the y-axis. This is at 14, and this one is at 5. So again, looks like a trapezoid. And what am I doing? I take half of the height times base 1 plus base 2, or really half of delta x times the f at 1, the function defined at 1, plus the function defined at 4. That's what I did. So 1/2 delta x is b minus a. And so I would get 3 times f of 1 was 5 plus f of 4 was 14. So, boy, 57 over 2. All right, last and final one. The integral from 0 to 2 of 1 plus 4 square root of 4 minus x squared plus the integral from 2 to 5 of 3 minus x dx. So we're going to do properties here, actually, because this is adding, and we've already done this, and this is a constant. So using properties, I'm going to separate this into the integral from 0 to 2 of 1 dx plus the integral from 0 to 2 of the square root of 4 minus x squared dx. And I'll do this part in a minute. Let's just do this first part right here. So the integrating a constant, remember, is the constant times b minus a. So that is just 2. Plus this we had done from part 1. Would do to this. In part 1, we went -2 to 2, but we have to go from 0 to 2. Don't you think that would just cut this in half, the area that this was in half? We're going from 0 to 2. So that's a half of this area. So a half of 2 pi is pi. So 2 plus pi is that first part. And then let's use properties for the second part right here. This would be the integral from 2 to 5 of 3 minus the integral from 2 to 5 of x. And that one's easy. Again, that would just be 3 times 5 minus 2, which is 9. And the integral from 2 to 5 of x, well, again, if you notice, we were doing a line here and a line here. And what did they both end up being? They kept being trapezoids. So if I just do a trapezoid formula and I follow this trapezoid formula here, I would just do 1/2 delta x times f at 2 plus f of 5. So this would be 1/2 times delta x was 5 minus 2, which is 3. F of 2, plug 2 in here, I get 2. Plug 5 in there, I get 5. You could draw it out to double check, but that's what always happens with those lines. They just are trapezoids. So 9 minus 10, 5. 7 times 2 is 21. 21 times 2 divided by 2. Sorry about that. Which would be because we're going to combine it with this one. And so 2 plus pi plus 9 minus 21 over 2, which would be a total area of pi plus 11 minus 21 over 2 pi over pi plus 1/2. Okay, so try some examples for yourself. Have a good day.